So we're asked to find the dimensions of a tank that minimize the amount of material used. The condition we're given is that the tank must hold 32 cubic feet of volume. So the volume needs to be 32, and you're trying to minimize the area. The other important fact is that the tank has an open lid, so there's no top side of this box there. So I'll name the sides x, y, and z, and then I'll write a function for the area. So I'll say area equal to, so the bottom, maybe I should do it more carefully. It's xy. There's two sides, one on the left, one on the right, so this one and this one. So 2 times y, z, right? That's the area for each of those rectangles there. And then there's the front and the back. Okay? So that will be 2 times x, z. So base times height here. So that is the area. The condition that the volume is 32 translates into x, y, z equal 32. So I could as well get rid of z and say z equal to 32 over xy to turn that into a function of x and y only. So a of xy equals xy plus 2y 32 over xy plus 2, and excuse me, that was a z, correct? The face was x times z, so that here is a z. So that's 2x here times the z we just found, 32 over xy. So if I write that a little better, that is a function of 2 variables we need to maximize, or actually we need to minimize it. So that will be canceling the y's, xy plus 64 over x minus 1 plus cancel the x's, 64 over y minus 1. So we're looking for the minimum value of this function. Pretty easy thing to do if we note that this is the area, so it's a positive function for sure. If it is to have a maximum somewhere, the maximum is supposed to have horizontal tangent plane, which means the gradient of this function needs to be 0. So the gradient of a is, first coordinate is dA dx, second is dA dy, so that will be deriving with respect to x, that is y minus 64 x minus 2, comma, deriving with respect to y, that's x minus 64 y minus 2. For that to be 0, 0, we need both conditions to be satisfied at once. Y is minus, y minus 64. X to the negative 2 equals 0. X minus 64. Y to the negative 2 equals 0. Okay? So that's a nonlinear system of 2 equations. Let's see how well we can resolve this. So maybe using equation number 1, let's see what we get. Y equals 64 over x squared. And if I then plug this back into equation 2, which says x equals 64 over y squared. That will give me x equal to 64 over x squared. So I'm plugging in y as this into the second equation. This will give me a pretty clear idea of what to do. This will be 64 over big fraction, 64 squared over x to the fourth. To divide fractions, you multiply the first one by the reciprocal of the other. So you end up with x equal to x to the fourth over 64. So I could multiply the 64 and divide x to get 64 equals x cubed. Okay? What is an x value? What is a value that has cubed equals 64, right? X equal to 4. 4 times 4 is 16. 16 times 4 is 64. So x is 4. If you go back a couple steps and do this, you find y equal to 64 over 4 squared, which is 16. So that is also 4. X and y do have to be equal. And then to end up, remember the fact that the volume had to be 32 allows you to find z. So x, y, z equals 32. That means 4 times 4 times z equals 32. 16z is 32. Z equal 2. So this means our tank has dimensions. Pretty low tank there, because z was the height. It's only 2. This is 2. This is 4. This is 4. Maybe not as low as I thought. This is only half of this. So there you have it.